Hello, welcome to my video. Today I'm going to be talking about building a 3D level map procedurally with a random walk algorithm using Blender and Python. On the screen you can see an example of what that looks like. If we zoom into the model, you can see the mesh is hollow and navigatable. If you're interested in seeing a full run of the program from a fresh instance of Blender, check it out. Inside of Blender, open up the scripting layout, switched from the default layout. You'll be presented this big gray box. Move it over a little bit, open up a new text file, and if you clone down the Python file with this project, you could either import it here with the open, or you could just open it up in a text editor, copy all of the text, go back, paste it in, and hit the run script button. And there it is. You can then hit the button again and get two combined versions. And you can do that as many times as you want until Blender crashes. The basic idea for how this algorithm is implemented is that we start out at the XY coordinate point 0, 0 on the map. We randomly choose a direction of either up, down, left, or right. We increment X or Y accordingly, and then we place a cube at the new location. We repeat this process some number of iterations until complete. Once we've gone through all of the iterations, we can clean up the mesh and produce the final result. I have published the code on GitHub, so feel free to go there and clone it. I have provided the link in the description. Now let's take a look at how the code works. The first thing that we're going to do is import the random library from the Python standard library and import the BPY and BMesh libraries from Blender. We'll then set a constant called iterations to do 1000 iterations and place 1000 cubes. We'll define two other constants, the X move distance and the Y move distance, to control how much distance is moved in global space per iteration. The reason that we're using 2 is because the default cube size provided by Blender is 2 wide by 2 long, and so 2 will keep the squares nice and tight. And then we'll define a global position in space with X and Y, and that will keep track of our state as we go through. The main driver function of the program is defined on line 29 called generate maze, and generate maze performs a for loop over 1000 iterations as defined in the iterations constant, and for each iteration we get a random direction using the get random direction function, which gets stored in a variable called direction, and that gets passed into the next move function. If we look at the get random direction function on line 36, we can see it stores a little dictionary with 0 being up, 1 being right, 2 being down, 3 being left, and it uses the random.randint function, which comes from the Python random library, to store a random number between 0 and 3 and returns that as the direction. the direction that gets returned is passed into the next move function, which gets called on line 42. The next move function takes the direction as well as the global x and y position, and if, for instance, the direction is up, the y position is incremented by the y move distance, and we then place a cube at that new location. After all 1000 iterations are complete, we then call the cleanup mesh function. And the cleanup mesh function is defined on line 72, and it goes through, it selects all of the objects in the scene, which is a bunch of cubes. It then joins those objects using Blender's join method and toggles the scene into edit mode. It then takes that edit mesh data and saves it into a variable called mesh, and we then call the remove doubles to get rid of all the doubles that were created for all the overlapping vertices, and we then deselect everything in the scene, in this case all the vertices. We then select all of the interior faces, so everything not on the outside of the mesh, just inside. But that does include the top and bottom faces of the mesh. So the next thing that we want to do is, for each mesh face that's selected by the select interior faces, we want to determine if the normal is on a Z, 1 or -1 to indicate that it's a ceiling or a floor, and if it is, we want to deselect that face. And with all of the ceilings and floors deselected, we then want to delete all of the remaining faces, which would be wall faces, so that the mesh is left hollow and navigatable. And that's it. Thank you for watching, and if you like this video, please like and subscribe.